everyone, my name is Rifky Pramudita Mahendra, and in this part of the video I'm going to explain to you the part A. In part A, we are asked to describe and summarize the sample data given to us, and we also need to present it effectively in numerical, tabular, and graphical form. So as you can see on the left hand side of the screen, we are given sets of data, 200 sets to be exact. And in each set of data, it contains weight, relative density, tensile strength, and the shift information. So 200 sets of data is a lot of data. What we can do to simplify it is to create pivot table, just like this one. So in this pivot table, we can see the frequency of weight, same goes for the relative density, and also for the tensile strength. After creating the pivot table, we can also easily create the pivot charts. So frequency is one thing, but what about the other? We have also created tables of other summarized data. This one is average data. It is created based on the data sheet. For example, this is the data of average of weight for the evening shift using the average Excel formula. Same goes for the other data in this table. Also same goes for the standard deviation data, which uses this formula, and also for the range data. For the range data, we use a maximum formula minus minimum formula to get the range. So we have average, standard deviation, and range. But that's not all. We also managed to collect the median, the mode, the standard deviation, the sample variance, minimum, and maximum data, all by using Excel formula. This is for weight, this is for relative density, and this is supposed to be for the tensile strength. I'm sorry for the typo over there. But yes, these are the collected data, and that's all for part A.
Okay, for this task B, it says that the Food and Drug Administration (FDA) authority requires that weight of standard tablet produced by manufacturer should be normally distributed with mean 350 mg with standard deviation of 40 mg. It requires us to comment on whether there is significant evidence that lajak laku tablets produced in December 2020 do follow this normal distribution. So first, we build a frequency table from the set of data given by using Excel. So this is the frequency table that we get. Then we assume weight is X. So for H0, we say that X follow the normal distribution with mean 350 mg and 14 standard deviation. H1 doesn't means X does not follow the normal distribution. So by assuming H0 is correct, Z is equal to X minus 350 over 14. So by using this formula, we can find the probability for each weight by using the statistical table. So this is what we get for first table. Then we move to the goodness test table, which is here to find the chi-square test. So by using all this formula for each frequency, we get the chi-square test for each of our weight. After that, we say that K is equal to 5, which means V equal to 4. Since there is no additional variable, we say that P equal to 0. So chi-square test equal to all this total up, we get 6.3769. And alpha that we use is 0.05. And then at square alpha V is at chi square alpha v is equal to chi squared 0.054 is equal to 9.4877. So we see that since chi squared test is less than chi squared 0.054, we fail to reject H naught, which means we accept H naught and conclude that Lajat Laku tablets produced in December 2020 do follow the normal distribution with mean 350 mg and standard deviation of 40 mg. Thank you.
Hi everyone, I am Ahmed Magdi and I will talk about part C, which is the comment on whether there is any significant difference between tablet weights from the different shifts. So first, this is our table for group E. We just focus on the weights values. Then we will classify these values based on the shifts, night, evening and morning. So here we classified all the weights based on the shifts. Then we have the hypothesis statement. For each node, we'll assume there is no significant difference in a tablet weight from the different shifts at alpha equal 5%. And for each one, we'll assume there is a significant difference in a tablet weight from the different shifts at alpha equal 5%. And in the short form, for each node, we'll assume that all means are equal, mu1, mu2, mu3 are equal. And for each one, we'll assume that mu I is not equal to mu j for at least one ij, and I is not equal to j. So based on that, each node will be rejected if alpha, which is 0.05, is greater than b value. So how to get this b value? We go to data, statistics, analysis of variance, which is ANOVA. For our input range, we just input all the weight values. And for the results too, we just choose any place here to show the output. And type is a single factor grouped by columns, and alpha is equal to 0.05. So we get the ANOVA. So here we have alpha is 0.05, grouped morning, evening, and night. We count all the values based on the shift, and we have the sum of the values, mean and variance. Here we have the source of variance. SS is the sum of square, DF is the degree of freedom, MS is the mean square, and we have F value, B value, and F critical value. So we just need the B value, which is equal to 0.35, and based on the B value, we conclude there is no significant difference at 5% level of significance, and we fail to reject each node because B value, this one, 0.35, is greater than alpha, which is 0.05, so we fail to reject each node. I think that's all. We go to part D.
Assalamualaikum. My name is Ihsan from Group E on question D. In this part of question, I'm given a question about to analyze some data from the given the relative density values 68%, 74.3%, and 80.1%. From this data, I was given the task to predict the tensile strength for these three values and to confirm the validity of my prediction. And so first, I input all 200 data into regression data analysis in Excel, and then obtain the value of 0.84 in multiple R and 7.71 R square, 7.71 with different adjusted R square, and 0.1 standard error. In summary, the output from using Excel, the significance F of the regression is 2.00 to the power of negative 56, so very, very, very low. And then the table 3, we get the intercept value at negative 0.10 and relative density of 0.08. We can see also the p-value is 2.00 to the power of 10 to the times 10 to the power of negative 56. Same also with the previous. And then we put this value, the first values, the coefficients of intercept, the y-intercept, negative 0.1, and then the relative density 0.08 as the gradient, and then input all the relative density values into the formula. 68 into the x, same way as 74.3 and 80.1 into the x, multiplied by 0.08 subtracted with 0.1, which produce the result of tensile strength of 5.43, 5.94, and 6.41. And conclusion on the last part, the correlation coefficient R equals 0.84. It falls into a strong correlation between x and y. And then the significance f, which is very low value to the power 10 to the power of 56, falls below the alpha of 0.05, which means there's significant effect between x and y. The prediction model used to predict the tensile strength of its relative density is valid in confidence interval of 95%. So that's my presentation, Party. Thank you very much.